Finally, I'd like to officially welcome you to the first session. And our first presentation is going to be from Christine Sternberg from FNR. This is our agency for renewable energy or renewable resources, and she'll give us an overview of the project. And then we've got two more speakers, Vytautas Akspinas from the Lithuanian Energy Institute and Sebastian Voth. And we'll introduce them as it becomes their time. And I'd like to give the floor now to Christine and let her tell you a little bit more about our project, and hope that you enjoy the presentation.
I will start with giving you a short introduction to the project, which the whole topic evolves around. And so what is coastal biogas about? I mean, as you all know, it's already the fourth conference of this project. And so for some of you, this might be a repetition, but for some of you, I still want to once again state the key facts of coastal biogas. And that is that it is actually a funding it is based, or it gets its funds from the Indirect South Baltic program. And the project budget is about €1.5 million. It's a 3 years, 3 year long project, and we work together with 6 partners from 5 different countries, mostly university and research institutes. So it's quite scientifically based. But of course, we also look for stakeholder contact and exchange to not lose the contact to the field, and which is also guaranteed by several different case studies that we have a closer look at, and also a collaboration with other like-minded projects. This picture nicely depicts the distribution of the different partners, and the whole project is coordinated by FNR, but that was also already told by Angela, the Agency for Renewable Resources in Germany. And the partners, you can see here, are from Denmark, Lithuania, Sweden, and also Poland. So what is coastal biogas actually about? The main problem which we try to address is the enrichment of nutrients of the Baltic Sea, which causes, as you certainly know, eutrophication, and which is quite a major problem of the Baltic Sea, causing negative consequences for the environment. But also has negative social effects. So our approach actually is to remove the seaweed that is washed ashore, and we had a look, or have a look, at different collection methods and techniques. And then we try to use this waste. I mean, this is a question of definition, obviously, but we see it as a waste because it's not used for any other purposes, and the beaches are supposed to be clean, and so we use this as a resource for anaerobic digestion, so as an input or a co-substrate for biogas plants. And and there we can transform the substrate into energy, which can be used for electricity, but also for heat generation on a local level. And then there remains obviously something in the biogas plant, which is the digestate, and our aim is to close the whole nutrient cycle by using this digestate as an organic fertilizer. aiming to replace fossil fertilizers on the fields. Yes. And with this approach, where we hope that we can reduce the nutrient content, the overload of nutrients in the Baltic Sea. Okay, this slide just shows what I just told you, the objectives of the project. Did I miss anything? No, maybe the last point, we try to we have already done this, of course, to report about our results and about our findings, and aiming to produce useful useful tools and knowledge for the relevant stakeholders. Also information for the policymakers in order to influence the way how we should deal with the seaweed that is washed ashore. This slightly maybe confusing picture depicts the whole technological chain of the project, and which again shows you how our what the whole approach of our work is. So it starts with the seaweed collection, then actually different pre-treatment steps are assessed by our scientific partners. And then it will be, or it has been already determined what are the most promising pre-treatments. I mean, some of them are not economically feasible. And then we give respective recommendations, obviously. And then there are two ways that we can use the substrate. Either it goes into the biogas plant, or it goes. It will be used for gasification with the syngas production. And then, as I already said, the biogas is used to create heat or power. Or the biogas can also be upgraded, obviously, to biomethane and used for as a transport fuel. Then there is the organic fertilizer, which we could use on the field and replace the fossil fertilizers. As I also mentioned before, different collection techniques have been investigated. As you can see here, different collection methods, like collection on the beach, collection in shallow water, and also in deep water, have been assessed, and and the results you will find in the respective reports that have been produced by the partners of Coastal Biogas. With pre-treatment, same story. Different pre-treatment methods have been investigated: physical, chemical, physiochemical, and biological treatments. And you will also find the results in the corresponding reports. So what outputs have we already achieved, actually? If you have a look at the Coastal Biogas website, you will see that two reports have been published already. The Coastal Biogas report on potential of using seaweed in biogas plants, and also policy frameworks that are relevant for using the seaweed. And additionally, also a report on operating biogas facilities utilizing anaerobic digestion of cast seaweed, to give a bit more details on the whole process. And as I said, you can check this out on the Coastal Biogas website. And you can expect pretty soon the publication of 2 other reports. This is once the nutrient recycling and energy recovery from thermal gasification of digestate. So here the focus was on the digestate and not on the biogas. And we will provide further details on this subject. And another report is on beach cleaning and development of biogas plants based on marine substrates, as we are aiming, obviously, to enlarge this whole sector and to make marine substrates interesting for biogas plants. Then I also would like to mention the Coastal Biogas newsletter. For the ones of you that haven't subscribed them still, please do so. That's pretty easy to do on the website, and it's free of charge, of course, and you will receive updates and more detailed information, and you will see what is actually going on in the project and which new findings we have, but also some more information on relevant and like-minded other projects that we collaborate with, and if there are any conferences or other publications, you will also find this in the biogas newsletter, the Coastal Biogas newsletter. Furthermore, which is maybe interesting for you, an information kit was already published on the Coastal Biogas website, and which is really interesting, and which is also available in all the different languages we are active in the Coastal Biogas project, which is English, German, Polish, Swedish, Lithuanian, and Danish. And in the information kit, you will find more information on the topics that the Coastal Biogas project addresses, which is eutrophication, seaweed in general, biogas, the organic fertilizer, is the digestate that we try to promote as using as organic fertilizers. At least in English, there are further information material, like educational material, which is basically some topic-related quizzes or I don't know. You can check this out. It's, I think, quite interesting, and the Coastal Biogas partners have done quite a good job, I think, to promote the whole subject in a broader way, and to get maybe other people also interested in this topic, which is quite relevant, we think. Here is, did I miss anything? No. The address for our Coastal Biogas website, so pretty easy to find. Also, when you don't remember this, just type in the project name into Google or whatever, and you will find it pretty easily. And here, as I said, you will find more detailed information. You will find also information about past events, where we included a summary, and also the newsletter is available, of course. Okay, I used up too much time, I guess, Angela. Okay, but it's already, that's not so important. Fine. Well, thank you very much for your attention.
I want to thank you for your presentation, Christine. And I also wanted to say we have one question, but I think this question is better for Tüge and Sebastian. In biogas plants, how much volume of methane comes out of 1 ton of seaweed? It's very different, but I think this is a question at the latest for our panel discussion, but maybe before. And how much seaweed will be collected or is taken away from the shores? We'll get to that. And I think what was also important about your presentation, Christine, was that you said it's waste. I think it's good to clarify that's not what we think. We don't think this is waste. Yeah, it's this is the classification in Germany, unfortunately. but it's definitely something that is very complicated. And we're talking about excess nutrients. Excess nutrients, not something that is just natural. It's too much. We're saying there's too much because of the eutrophication, and it could go back into the water and cause more eutrophication. That's why it's difficult. But hopefully, our next speaker can tell us a little bit about that. We're looking forward to your presentation, and I think you've done a lot of research on the nutrients that run into the water, and can give us your opinions on what we can do about it or how the situation is in Lithuania. And so the floor is yours.
Yes, hello, dear colleagues. Can you see my screen? Is it shared already?
Yes, we do. Thank you.
Okay, so I would like to introduce all attendees to the potential and policy frameworks regarding cast seaweeds, and in terms of coastal biogas project, the results is based on the deliverable 3.3, which is could be found on the coastal biogas publication section, and here you can see the all contributors who were involved into the preparation of such report. And let's start from the study area, which is consist of the Baltic Sea. It is quite close sea all around the world because it has only some narrow straits near the Denmark Islands and between the Denmark and Sweden. Therefore, this sea have a weak mix with the Atlantic Ocean and other wider waters. Therefore, it is highly depends on the freshwater inflow from the rivers, because due to the small surface area, which is due to different sources vary between 365,000 square kilometers up to 420,000, and the water which is collected from the watershed, the area consists of 1.7 million square kilometers, and most of this area is collected by 5 biggest rivers, which cover it southern, eastern, and northeastern part of this catchment, and it covers around a half of the whole catchment. These basins also provide a weakness and strength for the Baltic Sea, because the strength is a regular inflow of fresh water, but the weakness at the same time is a discharge of organic matter. And due to these reasons, the research issue to evaluate the potential is eutrophication in the Baltic Sea, because 75% of nitrogen and up to 95 to 99% of phosphorus enter from the rivers and direct point of sources. And as I mentioned before, it is discharges directly from the fields by the river networks. And according to Helsinki Commission, in other words, the Baltic Marine Environment Protection Commission, at least 97% of the sea area was assessed as eutrophied in 2011-2016, and the main reason for that it is the supply of organic matter from the rivers and direct point sources. And who is the most larger providers for the nutrients? And as you can see here, for nitrogen, the first place is for Poland, then Sweden, Russia, and Latvia. For the phosphorus, the situation is quite similar because the Poland is the highest supplier on the fields and the consequently mechanisms. And it provides favorable conditions for the growing of microphytes. And here you can see the number of different species which can be found in different places of the Baltic Sea. And according to that, our research interest is macroalgae, and if it is more concrete, is cast seaweed. And the most populated groups of the macroalgae is brown algae, where you can see at A, then green algae, red algae, and eelgrass. And it is the most populated species groups, and the more detailed list of species can be found in the report of this deliverable. And the research object for this project is cast seaweed in the Baltic, in the Baltic Sea area, which is marked by the red line for the 5 different countries. And let's dive into the potential of cast seaweed and begin from the Sweden. The Sweden were evaluated for the southern part of this country, and it was quite confusing evaluation during the preparation of this report, because there are tons of information and not of them are significant and trustful. Therefore, we decided to take the most important ones. And according to 2 different sources, which one of them consists of the 17 kilometers of the coastline, the second one covers the Scania region of 35 kilometers, and found that the available annual cast seaweed can reach 10,500 tons per annual, and in the higher, longer coastline, 21,000 tons per annual. And if we will divide from the coastline length, we get around 615 tons per kilometer per annual. And after evaluation of the coastline with and without protected areas, we get such numbers for the total amounts for the Sweden. And it is theoretically can reach up to 978,000 tons per annual in Sweden. But it is important to state that we do not evaluate the coastline of small islands. It is only the coastline of the mainland. The next one, potential in Denmark. In Denmark, the situation a little bit better, because there are more information due to the amounts of cast seaweed. And according to the concluded numbers, for example, for Solarate municipality, it is evaluated that annually it is normal to get up to 1,500 tons per annual from 3.7 kilometers, and it is around 405 tons from kilometer per annual. But there are some exceptions when the amounts reaches up to 4,000 tons, and if we will recalculate, it will be around 1,000 tons per kilometer. And according to provided data from the project partners and from Roskilde University, it can vary from 4 up to 500 tons per kilometer. And across the country and South Baltic Sea region, it will be 1,200,000 tons, or according to our evaluation, if we will assume that the average potential it is 405 tons per kilometer, it will be 795,000 with protected areas. And constantly it is less if we will reject or do not include protected areas. In Germany, a situation a little bit different because the amounts get lower from 1 kilometer, and according to the literature review, it is around 50 tons per kilometer, and as you can see, it is theoretically can reach 90,000 tons per annum. The potential in Poland, this country has quite a long coastline, but the amounts also differs from the different parts of this country, because in some areas it feasible that it's an average can be only 25 tons per kilometer, and it could be only real numbers for this country. And consequently, the critical potential of cast seaweed in Poland can be 17,000 tons. In Lithuania, the most stressful resource was the data from Palanga city municipality, which is managed 25 kilometers of coastline, and according to 2018 data, it was in total collected 50 tons, only 50 tons per annum. And if we will recalculate, it will be only 2 tons per kilometer. But there was also some exceptions during the last decade. 10, there was up to 400 tons per kilometer. But we assumed that in average it could be only 2 tons per kilometer, and with protected areas, theoretically it could be only 190 tons per annum, and consequently lower without protected areas. And if we will conclude all of these numbers, the total amount for the South Baltic Sea region, it could be near the 1,800,000 with protected areas, and if we will exclude them, it will be 1,200,000 tons per annum. And here you can see some distribution patterns when the amount of cast seaweed per kilometer decreases from Sweden eastward.
Tauters, are you about finished? Because I'm afraid we have to kind of wrap it up.
Yes, I will try. Okay, and then the policy frameworks regarding coastal protection. Probably we can show the Water Framework Directive, which is the most substantial piece of water legislation in European Union. That incorporates the water quality standards and integrates the principles of effective and sustainable development. then a marina strategy framework directive, which states what we should do that achieve the main goal for good environmental status in marine environment. Then the HELCOM, the Baltic Sea Action Plan, the European Union nitrates directive, also the Habitat Directive, which aims to promote the maintenance of biodiversity, taking economical, social, cultural, and regional requirements into account. Informs the cornerstone of Europe's nature conservation policy, together with the European Birds Directive.
And now our time is unfortunately up. I don't think we'll have time to go through.
And,
we already missed our question time. So, but if there's if you want to give one last closing statement, maybe there's something that we could conclude with. But I think we have to keep moving, otherwise we're going to get into a larger delay.
Okay, it is the most important documents for the potential seaweed as a potential for feedstock for green energy production and regulation on biogas plant establishment. It is also regulated by the following directives, their amendments and recasts of the directives, and it also could be found on the website in the report on the potential of cast seaweed and policy frameworks. For more information, every time you can find here.
I think that's a good closing statement, just to say we've got the information in the deliverable in the report, and we welcome you to go take a look. And I would love to have asked a couple of questions. We had not an extra question, but you also answered the question from the last, from Anonymous. Do we get the slides from the webinar? Yes, we'll put them online afterwards, about how much seaweed can be collected. I mean, Jürgen answered the question on Slido about how much was collected, and you answered the question about the potential. So thank you very much for your presentation. And we're going to give the floor now to Sebastian Voth, who is going to give us information about, thank you very much, about the nutrients and heavy metals in seaweed. And this is also very important for the circular economy uses of the seaweed. So, Sebastian, the floor is yours.
Yeah, thank you very much, Angela. I hope everyone can see my slides. My name is Sebastian Voth from the University of Rostock, and I'm member of the project team. I want to say thanks a lot for invitation as a speaker at our fourth Coastal Biogas conference, and it's a pleasure for me to speak today about nutrients and heavy metals in seaweed. So at first I want to say something about the background. As we know, the main goal of our project is to tackle eutrophication by catching nutrient load via biomass export and recovery. The value creation takes place in different stages of the cycle, as we can see later. From this point of view, it seems to be an important aspect to investigate the accumulation of nutrients and impurities like heavy metals to estimate the potential of retention from the biomass, a very important ecosystem service by aquatic biomass. And the motto is here, a lot helps a lot. When it comes to utilization, these values are also very important to determine the suitability of the substrate for utilization, because there are existing limit values. At the last presentation, we had an overview about the policy frameworks, and of course, I want to tell you something about the legal framework. As you can see, we have different basements. At first, European Union directives. They are implemented in German ordinances. So, for example, the Waste Framework Directive provides a general framework for regulation of waste management and provides basic definitions for all members of the European Union. The basic duties for the hygienic treatment and the examination of biomass that's classified as waste is implemented in the Bio-Waste Ordinance of Germany. According to this ordinance, the plant components of beach wreck, such as seaweed and algae, are declared as waste under a specific waste code for biodegradable waste. And these components are considered as vegetable waste from different sources than from households. So in Germany, they are classified as municipal waste and must be disposed in accordance with the waste management law. And the waste the waste law is opened at this moment when the washed up biomass is touched for collecting for further disposal in order to clean the beach. With regards to utilization on agricultural land, furthermore, the nitrate directive and its objective must be observed. It is in Germany mainly implemented through the German National Fertilizer Ordinance. And if the seaweed is used in biogas plants or in agricultural and cultivated land, it must comply with a number of limit values in accordance with the German Fertilizer Ordinance and the Bio-Waste Ordinance. And here you can see an extract of their holds for heavy metals and macronutrients in bio-waste applied on agricultural land according to the Bio-Waste Ordinance and the National Fertilizer Ordinance. And now I want to bring this to the value chain according to these limit values. I mean, the plant components of beach wreck are generally not dangerous waste. However, there's a basic obligation to treat and examine them before utilization. And then, according with mentioned regulation, it is possible to use as in energetic utilization for electricity, heat, and fuel, as well as material recovery as compost or fertilizer. The landfill of fermentation residues as digestate from biogas plants in which only conventional substrate are fermented is permitted on areas on organic farming. So with respect to German National Fertilizer Ordinance, only such areas of conventional agriculture are available for using these digestate as fertilizer. And when we speak about freshly washed up pure material, it can be recovered in mechanical biological treatment plants, or they can be used directly on agricultural land, but just with an exemption from the treatment obligations of the Bio-Waste Ordinance. So now I want to tell you something about our investigations. We made one-site sampling from 13 different locations along the Baltic Sea coast of Mecklenburg, Western Pomerania. 7 samples we took in April and 6 in May after storm events. And we concentrate our sampling on the species Zostera marina. The volume of the investigation was determined mostly by financial factors. Most of the lab tests were made in external laboratories. And the focus of the investigation was on important elements for plant growing, like macronutrients and alkali metals, as well as impurities like heavy metals. There are some pictures of different conditions on the beach. We were not everywhere able to get enough fresh and pure material from Zostera marina, but often it looked like this, so that we had enough samples for evaluation. Now you can see our results. We are concentrating on the elements you can see here, the macronutrients phosphorus, nitrogen, and carbon. the alkali metals potassium and sodium, and the heavy metals lead, cadmium, iron, manganese, and copper. So let's look a bit more precisely at the individual elements with corresponding markings for limit values. The red line is for limit overstepping and the yellow one for obligatory labeling. So what we can see here is that, for example, lead, we don't overstepping the limit values. For cadmium, for example, you can see that some samples are overstepping the limits, and for iron or manganese, we have the obligatory to label, but the obligation to label, but these values are not overstepping limits. The same with the other elements we investigated. So here you can see that in mostly it seems that substrate is suitable for utilization in biogas plants or general energetic utilization and material recovery. We also can compare the heavy metal contents with investigations from other projects. As part of the PROSIMA project, Regina Rollhäuser investigated nutrient and heavy metal contents in her master's thesis, and the responsible persons have provided us with data. And when we compare the heavy metal contents of the samples, it seems to be a gradient with different directions. And when we compare the nutrient contents of the samples, it seems to be actually no significant trend. So now I can make a short summary. Some samples are over the limits values, but not in general. It seems to be useful to collect more data to investigate the accumulation over a longer period. But in the case of overstepping these limit values, no direct use on farmland is permitted, and the possibilities are an accurate pre-treatment like vermiculture or blended mixtures of the substrate to stay under the limits. And in any case, however, the detection of nutrients and heavy metal load is necessary to ensure an efficient recycling. So I want to say thank you and ask for questions.
Yes, Sebastian, thank you. Thank you very much for your presentation. We do have one question. I'm not sure if we'll be able to answer this, but there's a question about why would iron be an issue if digesters are fed iron to reduce H2S? I think that, I don't know if you know a lot about the process biology of digesters and can explain that, but I think that this is a general fertilizer issue, right?
I couldn't hear the question very good.
Okay. If you're having problems hearing me, okay, there was a question on Slido. Why would iron be an issue if digesters are fed iron to reduce H2S? And I think that that may be a little bit out of your scope.
Yeah, maybe it could be useful to send me this question as an email so I can care about this topic.
Okay, but I think it's complicated because I mean you still have to. I don't think iron was something that was so critical. Obviously, also for that reason that iron is not that unusual in a digester, but cadmium, for example, was a lot more critical.
Yeah,
we have more. Has the analysis been made using seaweed species or seagrass? They are different.
as I said, we are concentrating on Zostera marina, so algae.
Okay. And Jana, also from Rostock, asked, did you use fresh or dried material for analysis?
We are collecting fresh matter, and of course we drive them before our investigations, and all the values are related to the dry matter.
Okay. So let us know if you needed a little more information, and you can always write to us if you want to go into a little bit more into depth.